everyone. Thank you. Good afternoon, and thank you for joining the session today about native apps for Windows on Snapdragon compute platform. My name is Phani Krishna Maringanti. I will be moderating today's session. Today's session is being led by Rami Husseini, Director of Product Management at Qualcomm, Ankit Kapoor, Chris Lewis, and myself. We are SMEs in the area, and we'd be happy to answer your queries throughout the session. Feel free to post your questions in the Teams chat during the presentation. And at the end, you will also have an opportunity to raise your hand and ask your questions during the Q&A section. Before I pass it on to Rami, a quick reminder for everybody that the session will be recorded and posted on demand after the event. With that, Rami, over to you. You can take control and move the slides.
Perfect. Thanks, Phani. Hi, everyone. First of all, I want to thank everyone for joining this Windows on Snapdragon session at the Microsoft Build Conference. We're real excited to kind of share all the exciting things about the platform and how to optimize your application experience for the platform. So my name is Rami Husseini, as Phani mentioned. Part of the product management team here at Qualcomm, really focused on the developer journey. We've worked with app developers like yourselves over the past few years to really bring the best app experience onto the Windows on Snapdragon platform. And we're excited to kind of share those experiences here. As far as the agenda, we're looking at kind of three main sections. First off, just providing an overview of the Windows on Snapdragon platform. Talking about how to really tune and optimize your application for the best experience on the platform. And then obviously the NPU, as we heard today as part of the keynotes, a lot of interest in different AI experiences on the Windows platform. And so we'll talk about how to accelerate that on the NPU. So yeah, so as we brought our Snapdragon technology into the Windows PC space, we really saw an opportunity to bring the best of the mobile phone experience into the Windows space. Starting off with market-leading performance. I personally use my Windows on Snapdragon platform as my main driver in the corporate environment, along with several other Qualcomm employees. And what you'll see as part of this slide deck, not only at Qualcomm, but there are several other enterprises also deploying these devices to their employee base. So you can naturally see that these devices have high performance, especially in the enterprise space. One of my favorite features is the multi-day battery life. So coming to Seattle for the Build Conference, I'm able to bring my device and not have to worry about charging the platform as I'm here for multiple days. The app experience that you get out of that is, from an app developer, you get longer engagement times with the solution. So your customers, your users are able to use your applications for a longer period of times, get better engagement, better activity because of this multi-day battery life. And we'll talk about how to tune your performance for the platform. The other area we'll kind of cover that's exciting is this dedicated AI engine. Naturally, on traditional platforms, you have a CPU for general purpose processing, a GPU for graphics processing. But what we've introduced is a neural processor, a separate hardware block where you can offload these AI workloads and run them concurrently on a separate processor. And I'm excited to share that as part of our demo booths here at the Microsoft Build Conference. You'll be able to see some really cool demos of some AI experiences running on the NPU. And then other areas that we also brought into the Windows PC space are around security, camera, audio, and obviously the connectivity with 5G cellular paired with Wi-Fi. So as we've kind of entered the PC space, it's been a multi-year journey. It's been multiple years of investment from Qualcomm, starting with the 835 and then now multiple generations of the 8CX platform. And as what you heard from our announcements in November at our technology summit, is we're continuing to invest and we'll continue to launch additional chipset platforms. But really what you see here is we're looking to drive innovation in the PC space and bring new technology into this space so that app developers like yourselves can really bring experiences and app features that are maybe not available on other platforms, and we'll touch into that here in a bit. As we look at the space, I'm real excited to share that it's the value props we presented on the previous slides is really resonating well across the ecosystem and across the different customers. As part of our technology summit in November, the head of IT at Citibank was talking about the platform and how it's a natural fit for the mobile workforce, and really kind of outline their deployment plan to their employees as kind of the solution for the modern hybrid workforce, along with some of these enterprises listed here who are also testing and deploying the platform. In the application space, a lot of app developer partners have really invested to optimize their solution and release native solutions, and that's a testament to both their vision that in the adoption rate of the platform, as well as the ease of use of the tool chain to port to Windows ARM. As you'll see here in the upcoming slides, the tool chains that are available make it such a natural, easy way to port your solution and optimize for the platform. And then obviously across the devices, multiple devices in market today across the market leading OEMs. So as we look at ways to optimize for the Windows on Snapdragon platform, really as a collaboration, what we want to do is bring the best experiences to market. So looking at these across the different vectors, obviously the natural one is performance. We want to leverage the ARM silicon, the Windows on Snapdragon silicon, and kind of deliver the best app experience. And in order to get there, it's really all about compiling your solution to run as native ARM64. The other advantage that you get by compiling to ARM64 is you get the power efficiency. So now your applications can run longer. You have better connectivity, through the always on, always connected capabilities. So you'll have 5G connectivity, and you'll be able to kind of access your cloud resources and really drive that power efficiency so that your apps engagement times run longer. We also have a dedicated NPU. One of the exciting demos that we'll have at our booth today at the Microsoft Build Conference is around Stable Diffusion. If you're not familiar with that, it's essentially a generative AI model where you're allowed to input a text prompt, and based on the text prompt, it will actually generate an image on the device. So you can essentially run that entire massive workload all on the NPU without having to access cloud resources, which is pretty phenomenal to run it all locally on the device. So please stop by the booth to check that out. And we'll also have our AI experts there who can share more details on how the models run. I think it's a large model, I think about 1 billion or so parameters, and they'll kind of give you some insights on kind of how to tune and leverage your AI experiences for the platform as well. In addition to AI, you have heterogeneous compute, so that allows you to kind of run different workloads concurrently on different hardware cores. And then we also touched up on the always on, always connected aspect. So how do you port for Windows ARM? Through working with several ISVs, app developers on the port, one of the feedback we've gotten from the developers is just how easy it was to port. After they went and compiled their app and got ready to release it, a lot of the feedback we get from them is, wow, Microsoft's done a great job with the tool chain to really just make it seamless. So it really is as seamless as the steps you see here. Basically, you grab Visual Studio, you set the build target to ARM64, you compile it. We'll share a set of devices with you on the upcoming slide that allows you to unit test your device or unit test your app on the device. access debugging tools to step through code and maybe debug any code. And then obviously, with the recent launch of Microsoft with Azure ARM VMs, you can now scale your CI automation pipeline to run your automation workloads in the cloud and release it. So in addition to the Microsoft tool chains and .NET framework, we also have third-party frameworks, UI frameworks like Qt, web frameworks like libceph, Electron, and Chromium. And what you see here is really just a small sample size of all the third-party frameworks that are out there, along with programming languages like Python and Perl and others. So you can see that the open source community has really adopted and started releasing native Windows ARM solutions for not just these logos, but many more and beyond. That way, it makes it much easier when you start to develop to be able to access those native ARM solutions and integrate them in and link them into your projects. Some of the key considerations here when porting to Windows ARM, starting off with the Visual Studio compiler. So if you want to run and compile your code natively, that has become available now as part of Visual Studio 2022. That way you can have Visual Studio running natively on your Windows on Snapdragon device. You can go ahead and compile your app natively be able to kind of unit test it directly on the platform. If you're on a previous version of Visual Studio, you can always cross-compile. So you could cross-compile on a different architecture, compile for Windows ARM, and then take that binary and then test it on a Windows ARM platform. Being able to cross-compile is available starting with Visual Studio 2017. One of my favorite features that got added into Windows 11 is called ARM64EC. And what that allows you to do is incrementally build your code to run native. So let's say you have multiple libraries, multiple components. Instead of having to compile everything to run native, you can select certain components to run native and allow other components to continue to run as x64 emulated. So this allows you, maybe if you have third-party dependencies that are x64, or if you want to maintain third-party plugins, you can leave your dependencies as x64, and then build your other components to run natively as ARM64EC. Because kernel mode drivers cannot be emulated, those naturally have to be built as native. And then the other recommendation is really looking at performance critical areas and making sure those performance critical areas are native. And then maybe some other areas that aren't as performance critical, maybe areas that aren't used a lot from a user perspective, those can continue to run emulated, and that way you have that hybrid model. The feedback we've gotten from many developers around ARM64EC is it's a great way to kind of move from emulated to native. We've gotten tremendous feedback, and actually a lot of the solutions in market start off as ARM64EC as part of their journey to full native. The other thing to note on emulation is only user mode code can be emulated, and for that reason, all kernel mode code needs to be compiled to run native ARM. So user mode code can be emulated, and kernel drivers need to run natively. And then the last piece is, as you build for ARM64, one thing we wanted to call out is ARM32 is being deprecated, so therefore there's no need to really target for that architecture and really kind of focus your native compilation for ARM64. And then really wanted, as we kind of pointed out on the previous slides, a lot of developers look for different types of platforms to test and develop on. So I just wanted to kind of share a list of different types of samples here where you can develop and test. So you have the Windows Developer Kit, you have Surface devices. Obviously, you have the Azure ARM VM where you can spin up VMs to either prototype your solution or run CI workloads. And then obviously third-party devices such from Dell, Lenovo, HP, and Samsung, and others. So this is just a small sample size, but really a mix of different platforms, different price points, different form factors that you could use for your development and testing. So now we'll touch up on the AI experiences. As you heard from the keynotes today, running AI on the edge is really critical. As new experiences come to the edge around productivity, around generative AI, even think about video conferencing with all the AI workloads on that. You have background replacement, background blur, noise cancellation, video super resolution, everything that you do in the creativity space. So if you look at photo editing, like all the neural filters, all the video editing, all of those AI workloads running on the edge, on the actual PC itself, that would bottleneck traditional CPU or GPU types of cores. That's why we're really excited to kind of have our Hexagon processor, which is our NPU, where you can run those workloads concurrently on a dedicated processor that's really custom built for AI workloads. And this can process scalar type of calculations, vector calculations, or even tensor. We have different hardware blocks within the Hexagon processor that's really tailored for those types of calculations that all bubble up to deliver the experiences listed here. And again, the really cool place to see this all come to life is at the Qualcomm booth at the Build conference, where we'll have different demos across different spaces to kind of showcase some of this. When you look at performance, naturally, when you build a dedicated hardware block, performance and power are kind of the key things that you're targeting, right? You want to have, because it's custom for this type of technology, we're excited to kind of share Procyon as a kind of benchmark tool that offers AI benchmark scores. And we can see here is that our Hexagon processor really delivers multiple times faster than what you get on a traditional GPU or CPU. And not only are you going to get the performance and power gains, but you're also getting the ability to offload the workloads from the CPU, GPU. And being able to run your workloads concurrently allows the CPU to really focus on the more traditional tasks. And you can think of that from a video conferencing perspective. If I'm able to run my background blur, my noise cancellation, my video super resolution, all on the Hexagon processor, then I allow my CPU and GPU to kind of handle the more traditional workloads as I multitask to maybe, do productivity work or others while in a conference call. How do you develop for the AI engine? The way you develop for it is really there's two paths. On the left side, you have your traditional AI frameworks, whether it be if your models are currently based on TensorFlow or PyTorch or Keras or Onyx, you can go down the Qualcomm SDK path, the neural processor SDK path, and then access the DSP, which is our Hexagon DSP. So that's how you can get a path down to our Hexagon DSP. The other path is through the Microsoft Onyx AI framework down through the Onyx runtime, also gets you access to our Hexagon DSP. So those are two paths down our software stack where you can access the DSP, and then you can also select to offload to GPU, CPU based on different workloads or different software architectural strategies. So again, some of the use cases that are enabled on here, if you look at generative AI, a lot of these are large language models or LLMs, really big models that really need dedicated processing. And so stable diffusion is one example of that, where you have text to image. We'll have, I believe, we'll have dedicated AI sessions at Build where we kind of provide additional context on that. So please look up Qualcomm sessions around the AI and the NPU, where we'll also kind of do deeper dives in that. But AI goes beyond that. So we're seeing a proliferation across enterprise security, where a lot of those technologies in NGAV moved from traditional virus scan lookup to more kind of behavioral analysis and deterministic models, and that's all ML AI based. When you look at photo editing, a lot of your neural filters, being able to kind of colorize black and white photos, replace backgrounds, those are all AI models. Productivity, we heard a lot about that today in the keynotes around, productivity type of workloads, along with video conferencing, workloads, and then also in gaming with super resolution, accelerated AI bots. So you're really seeing the AI experiences grow exponentially. And because of that, you really need a dedicated processor that gives you the performance power and then also allows you to run the workloads concurrently. So on to kind of end this discussion, we do have a developer portal that's up and running now. This is a great way to get how-to and tutorial videos, how-to guides on compiling, optimizing for Windows ARM, how to port to Windows native, ARM64 EC, as well as kind of deeper dives into the NPU and how to optimize your AI workloads for the neural processor. So please do go and get access to the site, log in, and start to kind of see all the assets there to help guide you through the developer journey. So appreciate your time. That's it. So I think, Phani, now maybe we'll open up for Q&A.
Awesome. Thanks, Rami, for a wonderful session. Now it's a Q&A time, so feel free to raise your hand, and that gives us an opportunity to enable your mic so that you can ask your question.
There are a couple of questions in the chat as well, if you guys want to take a look at that.
One of the questions from the chat was, is there a percentage for which apps are ARM32? I assume a lot of devs are already on ARM64, so that's why it's fading out. We don't have a solid number on that, but outside of UWP apps that sometimes had ARM32 packages, in all my years at Microsoft, I haven't seen an ARM32 app running on a system. So if it is out there, it's really uncommon.
Exactly. Yeah, and we just wanted to highlight it from the perspective of, if you are building for ARM64, just to kind of make sure that, help you minimize that scope and make sure that you're not also, expending resources and timing building for ARM32, which would end up getting deprecated. So it was more of a call out just to make sure it didn't go down that path.
And there is also a question, Chris, about cross-compiling from Visual Studio on Mac.
Honestly, I haven't personally tried that, but I can't think of any reason why it wouldn't work. Cross compilation has worked on Intel, and even, before we had native Visual Studio, I used to run older Visual Studio emulated and compiled fine off of that too. So I imagine you're not going to have issues on Mac, but if you do, let us know in Aperture and we'll help you fix them.
Awesome. Next question, is there a provision for running Android applications, Windows on Snapdragon? Yes, you can enable the Amazon App Store, and you can use Amazon App Store for Android applications on ARM devices. So that is a possibility. Vamshi's question, on what cases during AI training will Snapdragon NPU better than GPUs, or is it better for deployment runtime?
Ankit, are you available maybe to help with that question?
Yeah, maybe Rami, can you take that?
Yeah, I can take that. Let me reread it for a second. So on what cases during AI training will Snapdragon NPU be better than GPU? So good question. So a lot of, the way I would focus on the NPU for now is it's primarily used more for inference and executing the model on the edge. A lot of the training is still likely to be done in the cloud because you'll need, big data samples to, train the model and such. In the future, there will likely be an opportunity where training can happen on the edge too. But yeah, I would look at the NPU right now more from, from being able to kind of run your inferencing.
Thanks, Rami. There is another question from Mr. Robson around stable diffusion. What he wants to know more about stable diffusion and what is the system resources have been impacted. What is the impact of system resources by running stable diffusion?
Yeah, that's a great question. So traditionally, stable diffusion ran in the cloud, right? So if you go on, traditional devices, the model runs in the cloud. And what the Qualcomm AI engineering team has done is actually been able to kind of take that model and run that large language model on the edge. We initially showcased that at Mobile World Congress on an Android phone, and then today here at Build we'll showcase that on a PC form factor running. So you could essentially shut off all connectivity. You could shut off Wi-Fi and cellular and run the full stable diffusion model directly on the device. As far as the system resources, I know our AI team is doing a session where they will cover a lot of that. So I would probably would like to point you to that session if possible, to where they'll deep dive. The session will be done by Ankit Kapoor or Vinesh from Qualcomm. So yeah, so I would look into that. I see a question on here. Could you please comment if all apps in the store seamlessly run on Windows Dev Kit, ARM64? Are these natively converted by Microsoft or vendors?
Yeah, so Windows Dev Kit is similar to provide the same features as a traditional Windows on ARM device, like a Surface Pro 9 5G or a ThinkPad X13s. So all the apps which are available through Windows Store would work seamlessly on Dev Kit, similar to other ARM devices. And yeah, more and more apps are becoming available as ARM64, and you would start seeing them both on the store as well as Win32 downloads.
Yeah, and just to add to what Phani was saying, ARM32 apps, as Phani was mentioning, you can find them in the store, but then they can also be traditional, downloadable apps from the vendor website. So you can see them in both forms. Some of the recent launches include, I think over the last couple months, we've seen native app launches from McAfee and VMware. Obviously Adobe has their Photoshop and Lightroom apps, so really seeing a good breadth of applications across the different app categories.
Rami, there is also a question about the GPU. I don't know if that is something that you can answer.
Yeah, so does Qualcomm plan on building their future GPUs to be optimized for DX12, as it feels like the current Adreno GPU is built for Vulkan versus DX? Yeah, thanks, Franklin. Good question. Actually, our current on the Windows platform, our current Snapdragon architecture supports DirectX 12. There's a lot of partners who have built solutions, especially in the creator space, leveraging our DX12 stack. If you have any questions on the DX12 side, happy to answer that offline and connect you with our graphics team if there's interest to discuss that more. But yeah, it should run the entire DX12 stack.
Yeah, I think we're about time now.
All right.
Any last minute questions, folks?
Just to wrap it up, I want to thank everyone for joining. We're real excited about the Windows on Snapdragon platform and partnering with the app community to bring amazing experiences to the platform. So thank you for your time, and real excited to have Microsoft partner with us as part of this this presentation. So thanks to Phani and Chris and team, and appreciate the community for joining.